Lesson 9.11, identifying inverses graphically. What is an inverse? An inverse is a new function that's created by swapping the x and the y in each ordered pair. So it never changes the sign of something. It's just going to swap or reverse the x and the y in each point. What's kind of cool about this is it always will have a line of symmetry over the line y equals x. And if you think back to y equals mx plus b, this is really like y equals 1x plus 0. This is your y-intercept saying the origin. This is your slope, is the 1. So it goes up 1, right 1, up 1, right 1, up 1, right 1. So this line is going to be on there. This dashed line, it's just imaginary, but it is going to show you that this function is going to get reflected. So what I did is I just made a table, XY table of all these points that I could find that I call cross through the crosshairs. You know, if you ever shoot a gun or a bow or something that's got those sights on there, I want points that are on the grid lines, so I don't have to guess or make decimals. And so one of the points was -7, -1. All I have to do is swap that. So now I'm going to put a point at -1, -7. So -1 down 7 would be right here. 0, -2, I'd swap that and now make it -2, 0 right there. Now this would become -3, 5, -4, 8, -5, 9, 8, -6, 8. So you can see it start to come back down. -7, 5, -8, 0, and -9, -7. Can you see it? Can you see how this kind of looks like a butterfly is reflected? These points are equidistant from this center line here. These points equidistant, these equidistant, these equidistant. So it's called kind of diagonal symmetry. Excuse me. Okay, so then there's those. There's also sometimes linear functions that they want you to find the inverse of. I'm going to try to do it without making a table. And we just need at least 5 points. So this point is at 4, 9. Now I'm going to make a point at 9, 4. This point is at 3, 7. So now I'm going to put 7, 3. This point is at 2, 5. So now I'm going to put a point at 5, 2. This point is at 1, 3. So now I'm going to put a point 3, 1. And I'll do one more. At 0, 1 will be 1, 0. Ooh, pretty good line. So you can see again that there's symmetry here where these points are equidistant from this dashed imaginary line at y equals x, and that's an inverse.